Hi everybody, we are going to be watching a couple of videos to learn Standard 9. Before we do that, we need to review a few terms from Standard 1, the first one being angle bisector. If you remember, angle bisector cuts an angle into two congruent angles. So here we have angle ARE, and I'm trying to hold this camera, so excuse me if it's a little shaky. So I have angle ARE. Okay, and it says ray RB bisects angle ARE. So ray RB bisects the angle, bisects that whole angle. So it cuts the whole angle into two congruent angles, two equal parts. So now we have angle ARB is congruent to angle BRE. Now as we go through these, feel free to pause the video and take down some notes. We want to make sure that you get all of these down and really understand them, because the rest of S9 isn't going to make a whole lot of sense if we don't have these basic terms down. So our next one here is midpoint. Okay, midpoint is the middle point on a line segment. It cuts a segment in half and creates two congruent segments. So I start out with segment LR. Okay, I start out with that whole segment, LR. And this M, that's my midpoint. Okay, point M is my midpoint. That means it cuts LR into two equal segments. Remember, these tick marks is how we show we have two equal segments. So now LM is congruent to segment MR. Next, I have vertical angles. Okay, the angles across from each other, as you can see on this picture on the bottom left, those are vertical angles. Vertical angles are always congruent to each other. So here we have angles 1 and 2. Those are vertical angles. Those are congruent to each other. Now these, the top and the bottom angle, I haven't named those, but those are also vertical angles. They're also right across from each other. We have to make this perfect X if we're going to look at vertical angles. Okay, so these two are also vertical angles. So those are also congruent to each other. Next I have the reflexive property. The reflexive property just says that if a segment or an angle is equal to itself, so we have our triangle on the left here. Well, we have two triangles, triangle ADB and triangle ACB. So looking over here, I have this triangle and then this triangle. These two triangles, they share AB, they share segment AB. So I can mark it congruent to itself. Sometimes it's easier if we pull the triangles apart. Then we can see that the triangle shares AB with the other triangle. Okay, so we have these two triangles. I started out with these two. Split them apart so that I have them redrawn here. And I see that AB is the same on both of them. This helps us as we try to prove triangles congruent using our congruent shortcut. So that gives us the one set of congruent sides that we may need for using our congruent triangle shortcuts. Next I have perpendicular. Remember that upside down T? Okay, our upside down T, that is the shorthand way of writing perpendicular. Perpendicular lines, they create right angles. Okay, now they don't just have to be lines, they can be segments or rays as well as lines. So over here on our left, it says AB, segment AB, is perpendicular to CD. And I should change that. This should be line CD. Okay, we see in the picture that's line CD. Alright, so we know those two are perpendicular to each other. So we can say that angle AED is a right angle. Okay, angle AED. That's a right angle, or 90 degrees as we write right here. Angle AEC, that's also a right angle, 90 degrees. Angle DEB, 90 degrees. And CEB, also 90 degrees. Alright, then finally we have CPCTC. Now this one is a new one. It stands for corresponding parts of congruent triangles are congruent. So this just means we have proven two triangles are congruent using one of our triangle shortcuts. By using one of our triangle shortcuts, we've already said that we have 3 pieces congruent. But if triangles are congruent, then each piece has a matching piece in the other triangle. Okay, so if we go back up here to this one, if I had proven these two are congruent using hypotenuse leg, for example, then I would also know that these angles up here at the top, those are congruent. So once I prove the 2 triangles are congruent, then I can say the other pieces in the triangles are congruent. And we'll see a little bit more of that in our examples. Okay, make sure you have all these definitions written down before we move on. Okay, so with examples, we have number 1 here. Given angle SPR is congruent to angle QRP, and we have angle Q is congruent to angle S. What we're trying to prove is that angle PQR is congruent to triangle PQR is congruent to triangle RSP. Now remember, whenever we do our 2-column proofs, we are given some information, we're given our picture, and we need to prove that final statement. In this case it says show, but usually it says prove. I went ahead and first pulled my 2 triangles apart here. Okay, so I pulled them apart. I have this SPR, I have that triangle here, and triangle PQR, I put that here. Okay, now we're doing 2-column proofs. I set up my 2-column proof here. I have statements, I have reasons. There's my 2 columns. First thing I always do, write my givens. That's always my first statement. So I just do one statement at a time, one given at a time. So my first one is going to say angle SPR is congruent to angle QRP. So let's move this down slowly. Okay. So there's number 1. Sorry, there's a cat in the way here. All right, anyway, I need to mark that in my picture. So angle SPR, I mark that, is congruent to angle QRP, marked here. Okay. My next statement will be this given. Angle Q is congruent to angle S. Again, that's just a given, so my statement is angle Q is congruent to angle S, and my reason is given. So angle Q is congruent to angle S. Okay, so I used all my givens. All I see right now, I'm going to try to find a triangle shortcut to prove this. All I see right now for each triangle is angle, angle. Okay, angle, angle. If we were to flip this triangle the other way, then you could see how Q and S line up, this angle R and this angle P line up. Okay, so we need another thing. I see in my picture that PR is on both triangles. Again, I see that here and here. So I can say that as one of my statements. Segment PR is congruent to segment PR. Okay, my reason being that segments are congruent to themselves. That's the reflexive property. If you remember from the notes you already wrote down, reflexive property means segments are congruent to themselves, or angles are congruent to themselves. My reason here, or where I got that from, is the picture. Okay, other than, well, sometimes with givens, but usually everything other than givens, we put something in parentheses where we got that piece of information. In this case, it was the picture. The picture showed us that PR is on both triangles and therefore congruent to itself. Now, let's mark that. PR is congruent to PR. Okay, now I see angle, angle, side. Angle, angle, side. So angle, angle, side can be my shortcut used for proving the 2 triangles are congruent. So again, this 1, 2, 3, that's where I'm showing where I got my information. So angle, angle, side. With number 1, I have one set of congruent angles. So there's my first A. My second A comes from statement number 2, where it says that I have another set of congruent angles. Then finally, PR is congruent to PR. That came from step 3. That's my side. My congruent sides came from here. And then we're done with that one. Let's move on to our second one. Okay, this one I don't have written out already, so we'll just write as we go. So, first thing, 2-column proofs. I make my 2 columns. Statements, reasons, number 1. Okay, let's pay attention to what I'm given, what I'm trying to find. LM bisects angle JLK. And I also know that JL is congruent to KL. I'm trying to prove that M is the midpoint of JK. So I'm trying to prove that M is in the middle of these. So let's kind of work backwards a little bit here. Midpoint means it cuts something in half. So if I can prove MK is congruent to JM, then that would be enough to prove this. Well, if I can prove these are congruent, well, the way I can prove these are congruent is if I prove these 2 triangles are congruent to each other. If these 2 triangles are congruent to each other, then JM would have to be congruent to MK. Like if I could flip this over here, if I can prove that I'm flipping this triangle, I'm just reflecting this triangle, then that's enough to prove that JM is congruent to MK, and then M is the midpoint of JK. So, as always, we start with our given. I'm going to start actually with JL is congruent to KL. JL is congruent to KL, and that is just a given. And that's already marked in my picture. So let's go on to our second given. LM bisects angle JLK. That's a given. Now, when necessary, I take those pieces above that I just wrote down and use them in my next step. So I'm going to do that with my statement number 3. I know that bisects means cuts it in half, creates 2 congruent pieces now. So I'm cutting an angle in half, angle JLK, so that's this angle right here. I'm cutting that angle in half to create 2 congruent segments, or congruent angles, I'm sorry. So I'm cutting this in half with this segment to make 2 congruent angles. So there's where my 2 congruent angles would be. So half of it's over here, half of it's over here. Okay. Now I just have to write that out. I've already marked it in my picture. Just need to mark it out, or write it out. Angle JLM, angle JLM, so right here, is congruent to angle KLM. KLM, so this one right here. It's really important that we mark our picture as we go along. It'll help us in finding the shortcuts. So right now I see side for each triangle. I see angle for each triangle. That's all I'm given for my given information. Oh, I forgot this. Here we can put bisects creates 2 congruent angles. You might also see that as definition of bisects. And that came from our step 2. Our step 2 told us enough information so that we could come up with this. Okay, back to what I was saying. Right now we have sides, we have angles. So right now I have side angle, but that's not enough to prove 2 triangles are congruent. In my picture, I see LM is on both triangles. If you wanted to split them apart, you could do that. I'm not going to. I see that LM is in both triangles, and of course LM is congruent to itself. LM is congruent to LM. My reason, well, up here, my example number 1, I already defined a reflexive property, so I'm going to go ahead and put reflexive property again. Okay, reflexive property, remember, just means segments are congruent to themselves, or angles are congruent to themselves. Okay, so in this case, I just have a segment that's congruent to itself. That's the reflexive property. I got that information from my picture. Okay. Statement number 5. I think now I have enough information to say that I have congruent triangles. So I have side, I have angle, and I have side. So side, angle, side. Side, angle, side. And that is a valid shortcut for proving that triangles are congruent. So I'm going to say triangle JLM is congruent to triangle KLM. Now remember, our order really does matter here when we're writing a congruency statement. LM is my second and last, and we said LM is the same as itself. So second and last again, that has to happen. Okay, my LK is the same as my JL, so those have to be in the same spot. So that's a good one. We have this congruency statement written well. Remember, side, angle, side is how we found that. Now, which statements did we use to come up with side, angle, side? First, we had these sides, JL and LK, so that came from step number 1, statement number 1. My angles, right here, that came from statement number 3. Finally, last side came from statement number 4, LM is congruent to LM. Now, we're not quite done. In this one, we're trying to prove that M is the midpoint of JK. Remember I said, if we get congruent triangles, then we know each piece has a matching part. You wrote down CPC/TC. Corresponding parts of congruent triangles are congruent. So I have congruent triangles. Each piece has a corresponding part. For example, this angle is corresponding with this angle, and they're congruent to each other. This side is corresponding with this side, and they're congruent to each other. This side is corresponding, of course, with itself on the other triangle, congruent to each other. Same here. These two angles right here, those would be the corresponding angles, and they're congruent to each other. So we have enough information to say that we also have these angles congruent to each other and these segments congruent to each other. MK, we have enough information to say that MK and JM are congruent to each other. JM is congruent to MK. Okay, we know that's true because of CPC/TC, which you wrote down before. If you want a longer version, you could say each piece from congruent triangles have, that would be has a corresponding or matching congruent piece in the other triangle. Short form, CPC/TC. Okay. We knew that from step 5. Okay, this was enough information. Having a congruency statement was enough information to say each piece has a matching piece that's the exact same size, exact same measurement. Now I just have one more step. Step number 7 is going to be this, what we're trying to prove. M is the midpoint of segment JK. I know that's true because my two pieces here are congruent. That means M is right in the middle of them. M is right in the middle of JK if I'm saying that these two segments are congruent to each other. So I can do something as simple as my reason being definition of midpoint. Because the definition of midpoint is a point right in the middle of a segment, and it cuts the segment into two new congruent segments. And this came from step number 6. Number 6 was enough information to tell me this is true. Okay, then we're moving on to example number 3. Okay. Okay. Is that okay there? Yeah. All right. I'm given that SE is congruent to segment SU. SE, SU. And angle E is congruent to angle U. I'm trying to prove MS is congruent to SO. So MS is here, SO is here, same as above. The example we just did. We're trying to prove that the two triangles are congruent first in order to prove that we have pieces that are congruent as well. But let's think about this. In this case, if I'm trying to prove just this piece of information is congruent to just this piece of information, MS is congruent to SO, that means I'm not looking at the big triangle here. I'm not looking at these big ones this time. This time I'm just looking at this small triangle and this small triangle. So really, we don't care about this bottom part at all. I don't care about this one this time. Okay, that doesn't matter to me. I just want to prove first MES is congruent to triangle OUS. Okay, so let's use our givens to get that far. So first, of course, my 2-column proof, I write statements and reasons. My first statement is going to be my first given. Segment SE is congruent to segment SU. Reason, given. And I mark it in my picture. Statement number 2, angle E is congruent to angle U. It's a given, and I mark it in my picture. Okay, so I see angle and side for each triangle. Now I don't see a reflexive property anywhere. I don't see any segments or angles that are shared. I do see vertical angles though. I see this angle 1 and this angle 2. Those are right across from each other. We see the X and we see the angles that are right across from each other. Those are vertical angles. So angle 1 is congruent to angle 2. Oops. My reason? Vertical angles are congruent. That came from the picture. And of course, I want to mark that up. Now, I see angle, side, angle. Angle, side, angle. So that's going to be my reason for proving the two triangles congruent. Now, of course, I need to be careful in how I'm naming these triangles. So E and U have to go together. So E and U are first in my congruency statement. I see that S goes to those angles right there, just part of the name of those angles right there, but they're marked the same, so I'll put those second for both triangles. Then this triangle goes towards M. This triangle goes towards O. So triangle ESM is congruent to triangle USO. By angle, side, angle, my first angle were these, the E and the U, that came from step 2. My segments were step 1, and then my vertical angles were step 3. So my angles first came from here, then my side came from here, and my last set of angles came from here. So now that I've proven that the two triangles are congruent, that's enough to start saying every piece in this triangle has a piece that matches it in this triangle. So that would mean this angle right here, angle M, is congruent to this angle O right here. That would mean this segment ME is congruent to this segment OU. We're trying to prove MS is congruent to SO. So, mark that up. I know that's true. MS is indeed congruent to SO. CPCTC. Okay, so I have this triangle is congruent to, the triangles are congruent to each other. So that means every single piece in the triangle has a matching part. So we got this from statement 4. And there we go. Now we're done.